everyone, today we're presenting our final project report for CSIT5970, focusing on Steam review analysis. Our team members are Huang, Yanzhen, and Weijie. This report covers three key parts: introduction, methods, and analysis. First, introduction. The dataset used in this project comes from this link. The full dataset contains 100 million and more data records, which is not analyzable on a local machine. This is the core dataset we use for analysis on the Alibaba Elastic MapReduce service, or EMR service. There is also a subset that contains only around 500K records, which is used only for local testing and does not represent the primary focus of this video. The project repository structure is given as follows. The demo folder stores the analysis results, including the raw results we download from the OSS of the EMR platform and the rendered graphs. The resources folder is the temporary file storage for runtime. The tasks folder and the analysis.py file is for local testing only, which will not be elaborated in this video. The task/Alibaba folder stores all the EMR data analysis tasks. Next, methods. Now, let's analyze the dataset. Each row represents an author's review of a game on the Steam platform, and each review reflects the author's genuine feelings. Each column represents the characteristics of these reviews, allowing us to gain in-depth understanding of various aspects of the reviews. By analyzing these rows and columns, we can uncover players' opinions and preferences regarding the game, providing strong evidence for game improvement and promotion. A detailed meaning of each column is given in this table. In the dataset pre-processing stage, two key lambda functions were used. The first function is isRetain equals to author playtime forever larger than author playtime at review. The second function is isActive equals to author playtime last 2 weeks larger than 0. That is, we define reviewers who was playing this game in the last 2 weeks as active players. Additionally, we rename timestamp created to date. This operation helps more clearly identify the data and improves the efficiency of data processing and analysis. The task structure in the EMR version has 3 key elements. First is the task list, stored in the task/Alibaba folder. Each task corresponds to a .py file open for extension. The task list forms the basic framework of the entire task system. On the EMR platform, we clearly list and schedule all tasks to be scheduled through task scheduling. Next is task definition, which describes the computation method and storage format of each task by customizing task functions. Finally, there is the task template, which each task must follow. This provides a standardized process and specifications for task execution, reducing human error and improving execution efficiency. These 3 elements complement each other, together forming an efficient task structure. Each task depends on the /base.py file. This file defines an EMR analyzer class. After defining the class method, the task method, each task needs to pass the task method as a higher order method to the EMR analyzer instance via the setTask method. After this, the analyze method is started through chained calls to execute the standard analysis process. The EMR analyzer class serves to cache Spark and Spark data frame reference instances and to uniformly handle analysis functions, prologue and epilogue, simplifying the process of extending new tasks. Note that in the EMR analyzer, we accept an additional parameter in the analyze function. This parameter specifies the storage destination under an OSS subpath. This needs to be defined on the EMR platform. Furthermore, the dependency resolution of each task to /base.py file is also handled through the EMR platform. Next, I will discuss sparse parameter configuration. Since 100 million data entries is quite large, we will set the driver and executor memory to 64 GB and 128 GB respectively. The number of cores for both the driver and executor is set to 2, and the number of executor instances is set to 0. Task scheduling is natively implemented on the EMR platform, greatly facilitating task execution. The image is a screenshot of the task scheduling UI on the Alibaba EMR platform. In its last run on May 9, 2026, the entire task lasted for 1 hour, 7 minutes, and 1 second. Next, I will handle the presentation to my teammate Weijie.
Now we move on to the analysis section, where I will explain how the results were calculated and some interesting findings. Our first task is overall dataset statistics. Before other analysis, we have a clean global overview. The dataset contains about 114 million reviews, covering 38 million independent players and 100,000 Steam games. Our column analysis is feature correlation analysis. We selected 14 key features clean non-values, vectorize features, and calculate the complete correlation matching. The first finding is that user loyalty does not equal certification. Long-term playtime is positively correlated with user activity, but has almost no correlation with positive rating. Hardcore players are the most stable users, but also the most critical group. The first finding is that user loyalty does not equal certification. Long-term playtime is positively correlated with user activity, but has almost no correlation with positive rating. Hardcore players are the most stable users, but also the most critical group. Second, we found an obvious negativity bias in Steam review weighting. Positive review tests show a negative correlation with weighted most scores. It means critical and negative reviews are more likely to be marked as helpful by the community and gain higher exposure. Negative high-quality reviews dominate public game evaluation. Third, game collection behavior represents user influence. Users who has a large number of games tend to publish more reviews with higher community weight. These players are the core opinion leaders of the Steam community, and the platform algorithm obviously favor their feedback. Fourth, purchase behavior affects review sentiment. Users who purchase games directly on Steam are more likely to leave positive reviews. In contrast, users who get games for free have lower tolerance and are more likely to post negative comments when encountering poor initial experience. Fifth, review timing can predict user retention. Users who write reviews after long in-game play have a significantly higher long-term retention rate. Early reviews are most emotion feedback, while late-stage reviews reflect real experience and can be used to predict user lifetime value. In terms of game-level analysis, we found a huge market gap. CS2 dominates the platform with nearly 8 million reviews, 3 times more than PUBG. Besides, game times determine user sentiment. Classic sample games maintains nearly full positive reviews, while live server online games face more negative feedback due to frequent version updates and balance adjustments. From the perspective of global language distribution, English is still the mainstream, with over 51 million reviews. Simplified Chinese ranks second, with 17 million reviews, 15 times that of traditional Chinese, which fully proves the huge influence of Chinese mainland players on the global Steam community. Russian is the third largest language, forming the third core language market of Steam. For Chinese user regional distribution, we saw up the top active provinces. Guangdong, Shandong, and Jiangsu rank the top 3 in user activity. For game manufacturers, these regions are core market, suitable for high-performance hardware marketing and offline community operation activities. To further analyze user, we divide players into 4 tiers based on the number of on games: novice, intermediate, senior, and hardcore player. We use spark window function to mark each user's type and analyze the sentiment difference of different player groups. The result is very interesting. Player experience bring higher evolution standards. The positive review rate drops gradually as player type raise. We define user retention by comparing playtime before and after reviews. Globally, positive reviews have a higher overall retention rate. But for top competitive games like CS2 and PUBG, users who leave negative reviews have higher retentions. It means critical players are often the most loyal user of the game. We define active users as players with gameplay records in the latest 2 weeks. The data shows that esports competitive games have stronger user stickiness. CS2 and Rainbow Six Siege have the highest active user rate, 2 to 3 times higher than ordinary games. Competitive attribution and social interaction are the core driving forces of long-term user engagement. We also saw up the most popular funny reviews on Steam. These high-vol reviews are humorous and realistic, including playful complaints, interesting game experience, and community memes. They reflect the relaxed and active community atmosphere of the Steam platform and are an important part of user interactive content. The most discussed reviews focus on game bug, mechanism problems, operational flaws, and version updates. Different from funny reviews, these comments are more targeted, reflecting players' real doubts and dissatisfaction with game up quality, which is valuable feedback for game optimization. Influential reviews with ultra-high rate scores cover this diverse range, including game copyright discussion, features suggestion, player emotional sharing, and community hot topics. These reviews greatly guide the public opinion on our evolution trend of games in the Steam community. The most useful reviews are highly recommended by users. They contain real game experience, objective evolution, and community interactive contents. Finally, we analyze the long-term review chain of top games. Our analysis shows a clear difference. Competitive games see sharp spikes in reviews after updates, but are more volatile. Sandbox games show stable long-term growth with steady player activities. Thank you for your listening.